everybody. I'm Peter Defreyne. It says VIM, Flanders Institute for Mobility. For those who know us, actually, from next month we will be Antwerp Management School. So just wanted to say that at the beginning. Okay, there's been a lot of discussion on the roadmap towards automated vehicles. There's the business models, different applications, different challenges. But an important aspect actually is data, especially data on the infrastructure. Today you have companies like TomTom or HERE that are working on high-definition maps for semi-autonomous vehicles or autonomous vehicles. You have governments that are building infrastructure databases, especially traffic signs are a very important aspect of those databases. And actually you can do quite a lot of innovative things with those. You can build innovative applications with those, and I'll explain some of those in the second part of my presentation. But first and foremost, well, actually having a good infrastructure database or geographic database, yeah, it means it needs to be up to date. And if you look at your existing navigation device, well, it has the geographic map of your area, and once in a while you get updates. Nowadays it's more and more real time, but still every update needs a car that goes to a certain location with a lot of sensors to do a detailed measurement, and then you can get an update of the map. So it's actually quite expensive to build geographic information, infrastructure information, but also to maintain it. And especially maintaining it and updating it is something that we've done in a project called VEBIMOBE. Because if you look at modern cars these days, a lot of these cars have advanced driving assistance features. They are semi-autonomous in a way, and to do that they have a lot of sensors. They have radars, they have cameras, stereoscopic cameras to have some depth information, lasers, but also other systems, ABS, ESP, weather information such as temperature or raining. So actually all these sensors are generating huge amounts of data that are used today for the driver. We see now that with the connected cars and the platforms that are arising, okay, this is one of the main applications, the driving car as a data source in a connected platform and in the connected car. So we focused on this and looked especially in this project at traffic signs. You can buy a lot of cars these days that as a driver aid, it shows you the active speed limitation, whether you can overtake or not. So it's an interesting feature for the driver, but it's also interesting to provide information towards a central database of all the traffic signs. And this is something we did in the project. We wanted to benchmark how good actually are those sensors and what type of information does come out. And we've seen that actually speed is one of the most supported types of information that you can get out of these sensors. It's also one of the most interesting types of information. And we are currently looking into the reliability of these sensors. So, and I'll get back to that in a minute. And also, the role of the infrastructure provider, someone who builds roads and provides traffic signs. How can he build these things to take into account the quality of the detection by semi-autonomous vehicles? To do that, we are working together with Volvo, the local corporation, let's put it like this, but also with the guys from the R&D labs back in Sweden. We got access to internal canvas systems and could read out raw data from the sensor. And as I said, we are looking into this information chain. How can we go to raw detection data to useful information about the infrastructure? For example, if a car passes a new traffic sign and a lot of cars detect the same new traffic sign, then somewhere at TomTom or a government there could be a flag going up. Oh, there seems to be something new in the infrastructure. Perhaps we should go check it out and update our maps. So that's an important first aspect of this project. And then once you have this information and you know it's up to date, you can start doing all sorts of things with it. And I see that there's a lot of talk, for example, about speed maps for different applications. And I see there's actually a lot of confusion because if they, for example, have a traffic sign database, they think they have a speed map as well. But actually, there's quite a lot of steps to go from raw traffic sign data towards speed maps or sustainability maps or safety maps that includes, for example, school areas or built-up areas. So in order to get that sort of a higher level ITS information, you need to transform the raw traffic sign data toward this information. Because, well, what is traffic sign information? It's basically point data. It's a list of points that says, okay, this is a speed sign, this is the limitation, this is the start of a built-up area, this is a school area, this kind of information. But it's just points. You can't use it really at this point. So the first thing you really need to do is you need to attach it to an existing road network. And they exist. There's TomTom here, OpenStreetMap, so pick one. And what we've done is created an algorithm that looks, okay, this sign, it's in this location, it's close to this road. Is it part of this road? In what direction is it? It becomes more complicated once you get near an intersection. There, it gets a little more complicated, but we've developed an algorithm for that. The next step is, well, okay, you have these traffic signs. They are related to a road network. You want to go to this speed information. So basically, the next step in the algorithm is just applying road rules, the traffic rules, on how you should interpret the speed signs. And it can change depending on the country, but still it's actually quite simple because it's something you do every day once you're driving your own car. So this is what we did, and this is how we can generate a speed map, in this case, based on, in this case, TomTom. And finally, well, okay, you can do this for TomTom, but as I said, there are different vendors or platforms for geographic information and road networks. Well, we've also looked at OpenLR, an open protocol to transfer that information in between different networks, so you can use this higher level speed map on different types of vendors. So in the background you can see a picture of, well, this is almost all 50 kilometers an hour that was generated by interpreting speed signs. So that's an important aspect, going from raw data towards useful information that can assist in different types of applications. Because I've discussed speed, but you can also go looking for different applications, and I'll just mention 4 of them. I don't know how many of you know about ISA, Intelligent Speed Assistance or Adaptation. It's basically, the concept is that, especially if you have, for example, a logistics company, and you have a lot of accidents, or you have very high fuel consumption, or you go through a lot of rural, urban areas, where there's a lot of people on the road, pedestrians, cyclists. It might be nice if you could sort of limit the speed of your fleet to improve safety and fuel consumption. But to do that, you need a speed map. So you need a component that can interface with your throttle, your accelerator. But you also need to know how fast am I driving, and also what is the speed that I'm allowed to do. So this is a very interesting application, and we see that it's actually gaining momentum in our region to equip fleets with that. I'm not going to go too deep into that. I actually have a colleague here that's an expert on the matter. So that's one of the applications we are looking at. But actually, an infrastructure database, it can become a sort of ecosystem for different applications. If you make it user-friendly, if you make it open, you can do a lot of applications. You can use it to write police reports. You can use it in police courts. You can do sustainable routing. I'll discuss that in a minute. You can use it for mobility studies. Where are my really urban areas where there's a lot of pedestrians? Where are the schools? Where are built-up areas? And so on. So really what we want to do is make this infrastructure database an ecosystem and a community as well. An important aspect as well also is, I mentioned this in the beginning of the presentation, we were looking at the sensors of cars to update infrastructure databases and geographic systems, but also the other way around. If a traffic sign is not detected by the sensors in automated vehicles, what is the reason for that? Why does detection fail? Is it because of the weather, night, day, rain, sun, those kind of things? Is it to do with the size of the sign, the position of the sign? Is it too far from the road? Is it angled towards the road? The reflectivity of the sign. There's a long list of parameters that can actually influence the quality and the efficiency of detection of these sensors. So we are doing the exercise the other way around, and really providing advice towards infrastructures infrastructure builders, what they need to take into account to support semi-autonomous vehicles or fully autonomous vehicles. And then finally, a last case that we are working on is sustainability. You can know where the school areas are, where the very slow speed areas are, built-up areas. Well, actually, if you have a logistics company and you're doing, in this case, for example, our National Post company, well, if they calculate routes, you can actually take into account that these routes avoid areas where there's a lot of pedestrians and cyclists, so to improve safety. The other part could just be a rating of safety. If you calculate a route, you can at least say, okay, this is a good route, this is a bad route. You can compare and improve on that as well. So, and this as a service. So it's also an interesting model.
What is rat run?
Rat running, it's it's in Dutch. It's actually, if there's, for example, a lot of traffic on the highway, going through a city center to avoid congestion, and really going to the where the people live.
Sneak roads.
Sneak roads. Yeah, I don't think there's a general term for this behavior, except if someone knows a better one. But that's part of it. If you have a logistics company and a lot of people are rat running, are going through these areas, that's really a big truck, for example, shouldn't be driving. Then you can rate that and you can see, okay, how safe was this route for the area. So that's it really. This is the entire project, going from sensor to database to ITS layers of information to different applications. It's an overview of the project. If you have any questions, please come up to me afterwards also. So we have some discussion on this as well.
Any questions before?